Okay, so to do a five variable K-map, we first draw four variable K-maps, including consisting of the least significant bits, four least significant bits. Like if the five variables are A, B, C, D, E, where E is the least significant bit while A is the most significant bit, we draw four variable K-maps consisting B, C, D, E, these four variables. So these are like this, and then one of those K-map is assigned for A is equal to, this is for A bar, let's say, and this is for just A. So this is actually for A is equal to 0, and this is for A is equal to 1. So while transferring from the truth table, first this K-map is filled for the first 16 bits when A is equal to 0. First 16 numbers 0 to 15 goes here, and then when A becomes 1, the next 16 goes in the second K-map when A is equal to 1. So since there are 5 bits, we have 32 possible combinations. The first 16 goes here, the next 16 goes here. That's how it goes. So we have 2 K-maps here. Now we want to minimize this one. So the minimization procedure is exactly the same as the last one, the 4 variable one. So while we group, I will just show the grouping, then we will understand that. First we can group them individually, or we can group them together. If we have the same grouping in this one and this one as well, then we will group them together. Let's say this one first. This one is cannot go with anything else. If there was another one here, I would be able to group it with that one as well. So let's assume there was a one here, then I would group this one with this one. But since there is nothing there, I cannot do that. So yeah, I will erase that. Okay, so this one goes by itself, and the expression becomes, I will write the expressions here. Since this one is just by itself, so the expression is A bar, it will stay there, and this expression, which is this square, that is B bar, C bar and D, E. So all 5 of them, all 5 variables come here because this is just by itself. Looking at this one, I can group this one with this one. So this one can go with this one because they are in A is equal to 0 as well, in A is equal to 1. So the expression will be, there won't be any A, because it's also true for A is equal to 0 and A is equal to 1. So the concept is similar. So there won't be any A, it will be just B bar C. Let me write it in black as I was writing. So B bar C D E bar. That's the expression for this one. Now looking at, coming back to these 4 here, they can be grouped together. So this goes like that. Now this one's expression will be B here, this direction B here, and here it will be D bar. This side it's just D bar, and of course A bar, because it is not in A, so A bar has to come here. But for the last one there was no A because it was in both A0 and A1, as I said before. So yeah, now let's go to the next, the other K-map, the second K-map. This one has already been taken care of, but this one has not been taken care of yet. So I can group it, I cannot, there is no one here, so I cannot go there, so I can group it with this one. That's what I should do, because I want to make the group big, as big as possible. So here again it is becoming, since this is only in A, so this is A here, B bar C here, and then here it is D, because this one is just D here, because D is not changing from here to here. When I come here, this one has to, okay, let's look at these two first. These two can go with this one because it's common here. So what I will do here is the expression will be, there won't be any A again, so it will be just d bar e bar, sorry, and here it will have just B, no A and no C bar because C bar is also changing. So that's this one. For this last one, which is here, this one can go with, there is nothing here, so this one should go with just this one. So that will become the last one. It will have A because it is not in A0, so A is there, and then B, C bar, and then here it is E bar. So 4 variables because it's just a group of 2. So yeah, that's what it is. It's very, the concept wise it's very similar to the 4 variable one, and it's actually 2 4 variable ones combining together. And similarly, if it was a 6 variable k-map, it will be exactly similar, but then we will have 4 variable k-maps. So then let's say like we have a 4 variables 6 variable like A, B, C, D, E, F. So we will have 4 variable k-maps with C, D, E, F, and then the 4 will be one for A bar, B bar, one for A, B bar, one for A bar, B, and one for A, B, like that. So one for A, B. These 4 k-maps, and they will go exactly like, they will fill in exactly sequentially. So yeah, concept wise is just the same, but as the variable grows, there is practically it's not convenient to do more than 6. So yeah, for k then we have to use other methods, but up to 5 it's quite good using k-map, up to 5 variable, even up to 6 variables. Of course, for 6 variable case, the order of sequence will be, or the sequence will be like that. So A bar, B bar, and then A bar, B, then A, B bar, and finally A, B. But yeah, that's I'm talking about filling in from the truth table into the k-maps.